Today I'm returning to a problem that I posted my solution for recently. This is a viewer submitted problem, and if you watch the original video, which I'll link in the description, you'll see that I got partway through figuring out which of these options are true and false, and I was essentially incorrect when it came to my intuition on the remaining two options. But after I posted the video, I had an idea for how I might approach these two options, B and D, that have to do with showing whether a series is equal to some result or not. So in my original recording of my solution, I showed that options A and C are both correct. And my intuition was telling me that options B and D were not. The only real conclusion that I did come up about options B and D is that they can't both be correct. You can check my argument for that in the original video. But what I wanted to do is go through investigating whether option B is correct or not, or at least trying to compute this series with this new idea that I had. A comment was left on my original solution by the viewer that submitted this problem to confirm that option B is in fact correct. So I'm hoping that my approach will correctly derive the solution for option B. So I'm actually a little bit disappointed in myself for not having this idea the first time I went through the solution. But the idea is basically the following, that if I look at this series in option B, the sum as n goes from 1 to infinity of an divided by 10 to the power of n. Well, an is defined in terms of powers of these constants alpha and beta. And so I should be able to decompose the series into two geometric series. I'm not really sure how I didn't recognize that in the first place, but I'm just going to go through the details now of doing this computation. We have a closed form expression for the value of a geometric series. So I'm hoping that things simplify nicely to get this result of 10 divided by 89. Okay, let me show what I've done so far here. These constants alpha and beta come from the roots of the polynomial that are given, and using the quadratic formula, we can see pretty easily that these are the two values of alpha and beta, and we're given that an is defined this way. So what I'm doing is I'm defining a couple new constants, which I'll call gamma and theta, which are just alpha over 10 and beta over 10. And if I start with the sum that we're given, the series that we're given, and substitute what an is equal to and do some rearranging, then this is equal to 1 divided by alpha minus beta times the infinite series of gamma to the n minus the infinite series of theta to the n. Now it's pretty clear that both gamma and theta have an absolute value less than 1. You can see that from the values of alpha and beta. And so both of these infinite series converge nicely. There's nothing special about them, and we have a closed form solution for them. And I'm hoping if I just substitute in what this is in terms of gamma, and then make the substitution that gamma is equal to alpha over 10, do the same thing with the other series and do some simplification, I think I should just come out with a nice answer here. Okay, there we go. So if you're just careful about things, use the correct expressions for the sum of these two geometric series, it just becomes a bunch of algebra at this point. Nothing complicated, but just a little bit tedious. It was nice to use the identities, alpha plus beta is equal to 1 and alpha times beta is -1. We figured that out also in the last video. And when I make all the substitutions, I end up that this series is equal to 10 over 89. So my intuition in the last video was incorrect. Option B is true. So the complete answer to this question is that options A, B, and C are true. And again, if you look at my previous video, I give a very simple argument for why options B and D cannot both be correct. So we know that option D, the other infinite series, is false. Good problem. Thanks to the viewer for submitting this one. If I have any more to say about it, I'll put it in the description. Thanks for watching.